The final video for this section is, of course, my favorite topic, and that's the mental calculations. I know not all of you like that, and you've said so in some of the discussion board posts, said that it's not maybe your strong suit. Often I think that's because it's not emphasized enough, and we don't practice it enough. We rely on our devices a little too much sometimes, which is okay. But the more we practice, the better we get at it. It is a skill that can be developed, but it can also deteriorate if we don't use it. And with fractions, you may be thinking, there's no way I can mentally do fraction things in my head. I beg to differ. Hopefully, by the end of this, you're going to maybe find a couple new ways to think about fractions mentally. Before we get too far in, I just want to point out again, the National Council of Teachers of Mathematics says fraction symbols, right? When we write 1/4 or 2/3, we don't introduce that notation until after students have already developed the concepts and oral language necessary for symbols to be meaningful. And they should be carefully connected to both the models and oral language. All the stuff we've been modeling with pictures and images and bars and circles, they need to have that stuff mastered before we even go to this stuff, right? That stuff needs to be just built in, intuitive, solid as a rock, and they need to be able to explain it and describe it. Once they have done that and we introduce the concepts, then what I'm going to show you now becomes a little bit easier. Some of this stuff we've already talked about a little bit. And so one of the things you can do mentally is when you have to compare fractions that have a unit numerator, like 1/7 and 1/13, and you want to know which one's bigger. If you go back to this particular drawing, something we saw earlier, these shaded colored sections over here were all representative of a unit on top, number one, and then an increasing denominator. And we saw that as long as the numerator stayed constant as a 1, as the denominators got bigger, there had to be more pieces, so the size of each chunk got smaller. So if we're comparing fractions with a 1 in the numerator, we are always going to know that the smaller denominator will be bigger than the bigger denominator, right? That'll always be the case. So if I write 1/20 and 1/9, you go ahead and plop an inequality symbol between those. It's going to look like that. 1/9. A ninth is going to be a bigger chunk than a 20th is. So now let's turn that around and look at another scenario with this same chart, except I'm going to fill it in a little bit differently. In this case, I'm shaded in all but 1. So 1 out of 2. Notice how in each one of these cases, this represents 1/2. This represents 2/3. This represents 3/4. Agreed? And in each case, the numerator is just 1 less than the denominator. 1 is 1 less than 2. 2 is 1 less than 3. 3 is 1 less than 4. 4 is 1 less than 5, and so on. And so there's always going to be one empty section. And now, as our denominators get bigger, the value gets bigger. Because really what we're looking at is the chunk that's not shaded in. 5/6 means there's 1/6 that's not filled in. 4/5 means there's 1/5 that's not filled in. We know a fifth is bigger than a sixth. And so if we're thinking what's the leftover stuff that's not filled in, well, there's more that's not filled in here than here. So this value must be bigger than this one. And so we can do that with any two fractions. If we just say 13/14 and 21/22, which one of those is bigger? The answer will be the one with the, as long as the numerator is 1 less than the denominator, it'll always be the bigger one, the one that has the higher denominator. If you think about it in terms about what's missing, this one is missing 1/22. This one is missing 1/14 to complete the whole. There's more missing here than there is here. You go ahead and try that with one of these. Let's go 19/20 and 5/6. Go ahead and stick a inequality symbol between those. What's it going to look like? That. Think about the missing open section. This is missing a 20th to be whole. This is missing a 1/6 to be whole. And a 1/6 is a lot bigger than a 20th. So this one's missing a lot more than this one. So this is much closer to a full shaded in 1 than this one. So maybe you've never thought about it like that. Hopefully that gives you a new way to envision those fractions. So another great way to do some mental calculations with fractions is with what we call a benchmark. And being able to benchmark is a hallmark of number sense. Having good number sense means you can look at benchmark numbers. What do I mean by that? With fractions, it's often going to be 1/2. So if I give you this fraction, 3/7, is that more or less than 1/2? So if we sketch this out and we say 1/2 is right here, where would 3/7 be? Would it be to the left or to the right? If this is 0 and this is 1. The way you can tell is always by comparing the numerator to the denominator. Is 3 more or less than 1/2 of 7? Well, we can often figure that out by just doubling 3. 3 times 2 is 6. 3 times 2 is equal to 6. And because 7 is bigger than 6, then 3/7 has to be smaller than 1/2. 3/7 is smaller than 1/2. And you could sketch that out. You could see what a graph looks like. Again, 1/2 of 7 is actually 3.5, right? So as long as you're not at least halfway to 7, it's going to be less than. Here's another example. How about 5/9? 5/9. Is that more or less than 1/2? Think, is 5 at least halfway to 9? Well, if I doubled 5, what would it get me to? 10, which is bigger than 9. So 5 is more than halfway to 9. So 5/9 is greater than 1/2. This is a really, really useful strategy. And so you can see here, I'm going to show you a diagram of 3/7 compared to 1/2. There's that first one. And here's one for 5/9. Again, some visuals that go with those. The green half is on top, 3/7, 5/9. And it says right in the content standards for grade 4 by the Common Core standards, compare two fractions with different numerators and different denominators by comparing to a benchmark fraction such as 1/2. So we can not only compare numbers to 1/2, but we can also compare them to each other through 1/2. What do I mean by that? If I give you 5/8 and 4/11, and you want to know, is this greater? Is this less than? Which one is it? If you compare them individually, both to 1/2, I think you'll figure it out. 5/8 is bigger than 1/2. 4/11 is smaller than 1/2. 5 is more than halfway to 8. 4 is less than halfway to 11, which means this has to be smaller than this. So if we always think about 1/2 existing somewhere, in the middle, right? How does 1/2 compare to both of these numbers individually? Go ahead and try this one. comparing 9/20ths and 3/5. Does that get greater than or less than? So hopefully what you noticed there was that 9/20ths is not quite halfway to 20. So 9/20ths is less than a half. 3/5, well, 3 is more than halfway to 5, so it's bigger than a half, which means 3/5 has to be bigger than 9/20ths. This half comparison also allows us to do rounding with fractions. And maybe that's not even something that you would consider. Often we round with decimal numbers, but we don't often round with fractions, but we still can. How do you round with decimals? Don't you look at the next number, and if it's 5 or bigger, you round up. If it's less than 5, you round down. That's just comparing to a half, just like we're doing with fractions. So what we're going to do is I'm going to give you a mixed number, 4 3/7. And what you're going to do is we're going to round to the nearest whole number. So the way we're going to do that is we're going to look at the fractional part of the mixed number and ask, is the fractional part more or less than a half? 3/7. 3 is less than halfway to 7, which means this is less than a half. 3/7 is less than 1/2. So this would round down to 0, and we would say that this would be approximately the number 4 if we had to round it to the nearest whole number. It's either going to be 4 or it's going to round up to 5. Because we're less than halfway there, this will round to 4. Go ahead and try that with this one. This improper fraction of 8/3. Round that to the nearest whole number. So you might have first converted it to a mixed number. 3 can fit into 8 2 whole times with 2 left over, 2/3. Then we compare the 2 to the 3. The numerator is more than halfway to the denominator. And so this is going to round up. And so 2 2/3 will round to approximately 3. If you like a visual, because visuals do help, let's look at this number line. If we are looking at the fraction 3/8, and we have to round that either up or down to 1 or 0, you can see that this is the halfway point. This is the number 1/2. 3/8 is less than halfway to 1. This section is smaller than this section. 3/8 is closer to 0. So we would round it down to 0. Otherwise, over here on the right, if we're looking at 2 5/8, this is segmented off in eighths. This would be the halfway point. 5 is more than halfway to 8. So we have a smaller way to go here than we do here. When we're rounding, we are either going down to the nearest whole number or up to the nearest whole number. And in this case, 3 is closer. So the last part we'll talk about is approximations. And we can approximate with fractions just like we can approximate with decimals. The fraction, for example, the fraction 7/22. I have a hard time picturing what that's going to look like, how big that fraction really is, because it's got weird big numbers. But 7/22 is really close to another fraction where the numbers are nice numbers. They work well together. And that would be 7/21. Why are those numbers nice? Because we can reduce them by 7, leaving us with 1/3. So 7/22 is pretty close to 1/3. So there are ways that you can use your fractions to get some nicer numbers to work with. Why don't you go ahead and try a couple of these? The first one is the mixed number 4 17. Sorry, 4 17/30. just get an approximation to that. And then the other one is 19 over 80. Take a moment and see if you can approximate those. So what I notice here is that 17 is just a little bigger than 15, and 15 is half of 30. So I'm going to take that 17/30ths, change it to 15/30ths, and then this reduces to a half. And this is then pretty close to 4.5. So 4 and 17/30ths is pretty close to 4.5. And if you don't need an exact measurement, sometimes this is just good enough. How about 19 over 80? I'm curious what you did there. Well, 19 is pretty close to 20. And 20 over 80 makes a nice fraction. They both end in zeros, so we can divide by 10, which crosses off a 0. And then we can divide those remaining numbers, 2 and 8, by 2, and reduce right down to a 4th. So this is the last video in section 5.2. And all we've done here is we've explored different types of fractions. We've looked at the visualizations of those fractions. We've modeled them in all sorts of different ways. We played with common denominators. We've rounded, approximated, and it's all leading up to, I know what's next, which in section 5.3, we will be doing our operations with fractions.